highlighter, and they have, here's the definition of a rational function, is when you have a polynomial function on the top and a polynomial function on the bottom. For the most part, we will stick to lines and parabolas. But if you wanted to, you could extend it to have x cubed graphs in there, x to the 4 graphs over an x squared graph, anything like that. But on the exam, they tend to keep it to parabolas and lines and looking at the 3 different groups where sometimes the degree is bigger in your numerator, sometimes the degree is bigger in your denominator, and sometimes the degrees are the same. So we already saw this, but we'll talk about each of the characteristics of these graphs. The non-permissible values. You're not allowed to divide by 0, so if you had this as your equation, you would both have 3 and -1 as non-permissible values. If your non-permissible values do not simplify, if they don't simplify, you will always end up with vertical asymptotes at the non-permissible values. So maybe we put here a little arrow. If they cancel out and go away, you're going to have a hole. If they stay, and I wrote if they remain, then you're left with vertical asymptotes. So in this example, the x minus 3 and the x plus 1, the only way that those factors would simplify or cancel out is if there was something identical in your numerator. There isn't, so they become vertical asymptotes. In the second example in your notes, here, you have a factor that's identical, so you could rewrite this equation as x plus 1. This means you have a hole in your graph. And you can always find the hole by plugging in the non-permissible value into the simplified equation. Because once I cancel out those x minus 3's, my equation is now just x plus 1, which is really easy to graph because it's a straight line with a slope of 1 and a y-intercept of 1. But you're going to have a hole in this graph because 3 was the non-permissible value. Plug in that value of 3. If you plug in 3 for x, can you see it's really easy to see that the hole is at 3, 4. And I'm also going to, I always write hole. See if you can figure out why. You could also call it a point of discontinuity. Anybody guess why I like to write hole? It's easier and shorter. Yeah, this I like so many letters. Oh my goodness. But if on the exam they have point of discontinuity, I don't want you to freak out. Like, what is that? That's just a hole. And the reason it's called a point of discontinuity is we consider something continuous if you can draw it without lifting your pen. Notice I can draw this line no problem without lifting my pen until I get to the hole. Then I have to lift my pen, start on the other side, and keep going. So anytime you have to lift your pen at asymptotes or at holes, it's a place where the graph is discontinuous. And in this case, a hole is a point of discontinuity. All right, so let's go to example 1. And I'm going to get you to write this down. The steps for graphing rational functions. First, we are going to factor completely. So factoring is very important once again. Then list all your non-permissible values. And remember, non-permissible values are either going to be wholes or vertical asymptotes. And then in green, I wrote that if there is a hole, what's going to happen, I'm going to try to make this just a little bit bigger for you to see. If there's a hole, you graph the simplified equation and add your hole. So notice in all of our lines, once you canceled out that value, you got a straight line. You graph that straight line, but just add the hole to the graph. That's characteristic number 1. We're going to find out in characteristics 2 and 3 about horizontal asymptotes and oblique asymptotes, intercepts. So we're going to do our graphs all the way through, even though this question said just find if there's a hole or a vertical asymptote. We're going to graph every single one of them. So we're going to follow these steps through every single time. So you will have a horizontal asymptote if it is group 2 or group 3. In other words, if the degree is the same on the top and the bottom, or if the degree is bigger on the bottom, then you'll have horizontal asymptotes. If you have group 1 and it didn't simplify to just be a straight line, then you're going to have an oblique asymptote. Step 4, we're going to draw all of our x-intercepts and y-intercepts, and then we're going to talk about graphing some nice points, and I talk about graphing at least one point in each section. That'll make more sense as we do examples what we mean by that. And finally, you draw your graph through your points towards your asymptotes, and you'll be done. And now we're going to graph. So, steps for graphing. Here we are in part A. Factor completely. So I go to my equation, I can factor the top as a difference of squares, x plus 5, x minus 5, over x plus 5. There we go. Factor completely. List the non-permissible values. Our non-permissible value, and when you write a non-permissible value, you can say x can't equal negative 5. And in this situation, that negative 5 actually cancels out with the x plus 5 on the top. So I'm going to write in green here that my new equation is just y equals x minus 5. So what is our non-permissible value? Our non-permissible value is going to be a hole. And there's a hole at, and we would have our non-permissible value, that's the x value of our hole, and we find the y value of our hole by saying, now in this green equation, I could put in minus 5. Minus 5 would give me minus 10. But minus 5 stays a non-permissible value, so now I'll have a hole in my graph at minus 5, minus 10. So you're always going to find your hole by plugging in your non-permissible value into the simplified equation. Now the simplified equation, it's a line. You know how to graph a line, so we don't have to do steps 3, 4, and 5 at all. We can skip them because it's like, I already know how to graph a line. How do I graph a line? Well, I would probably start with my y-intercept being minus 5. So 1, 2, 3, 4, 5. Label that point. 0, minus 5. It has a slope of 1, so it means I go up 1 over 1. That finds another point. I could go up 1 over 1 again. I could find my x-intercept. It would not be hard to find out that if I plugged in 5 for x, I would get 0 for y. And my line's going to look like this, but on my line, I have to also label the hole that's going to happen on my line. So this would be graphing part A, a graph of the hole. So in part A, we have group 1. It starts with a degree bigger on the top, on the bottom. But since it's simplified, we graph the simplified version and add the whole. And since the simplified version was a line, we had no problem graphing that. Okay. Part B. Start by factoring completely. On the top, I can take out a common factor of 2. And on the bottom, I have x minus 2. List your non-permissible value. In this case, x can't equal positive 2 because that would cause you to divide by 0. And since the x minus 2 doesn't cancel out, you have a vertical asymptote. Are you okay with the abbreviation V dot A for vertical asymptote? Vertical asymptote, and when we write the equation of a vertical asymptote, it is x equals 2. The non-permissible value is where you can put the line through to say x can't equal 2, but when we write an equation of an asymptote, the key word there is anytime the question on an exam anywhere says write the equation, you need to have an equal sign in that and something on both sides. So the equation of the vertical asymptote is x equals 2. Okay. Sometimes you can start your graph right away, because we are going to graph all of these all the way through, even though the question doesn't say to graph completely. We could start by putting in our vertical asymptote at x equals 2. We still have a rational equation, so we're going to have to keep going through the steps. So number 3, does this one have horizontal asymptotes or oblique asymptotes? So we look at the degrees. Can you see that it was the same degree on the top and the bottom? Probably looks best even to go to the original equation. I have the same degree on the top and the bottom. Our characteristic was this has a horizontal asymptote. Where is that horizontal asymptote? If it's the same degree on the top and the bottom, then you look at the coefficients. See how we have 4 over 1? We are going to have a horizontal asymptote at y equals 4. So I can add that to my graph as well. That's step 3. Step 4, find all of your intercepts. The y-intercept is always the easiest. I would go to my original equation and plug in 0 for x. So I'm going to scroll back up. Really easy to see that if I plug in 0 for x, everything in that green box would be 0. And I'd just be left with positive 2 over negative 2. So my y-intercept is going to be at 0, negative 1. My x-intercept. Oh, almost had an E8 error for not closing my graph. My x-intercept. You find an x-intercept by plugging in 0 for y. Sometimes you can get more than one x-intercept. This is where factoring it is really helpful. Because if you have it factored, as in here, okay? I'm going to show you a step that you don't ever need to do, but if I do plug in 0 for y, can you see that you could multiply both sides by x minus 2? And if you multiply both sides by x minus 2, the bottom would just go away. Right? Because the one side, the x minus 2 would cancel out, and 0 times anything would just be 0. Now, you don't have to show that step, but this is very important, because the only way a fraction, and a rational equation is basically a fraction once you plug numbers in, the only way a fraction can ever equal 0 is if your numerator is equal to 0. And because we factored it, we can see right away that the only way that my numerator is equal to 0 is if I would plug in negative 1/2 for x. So I can go and I plug that point into my graph as well. Negative 1/2, 0. And this is where, in step 4, it says intercepts and nice points, 1 point in each section. What do I mean by sections? Well, in our graph, our domain is separated into 2 sections because of the vertical asymptote. I'm going to call this section 1 to the left of x equals 2, and this section 2 to the right of x equals 2. And in step 4, it says we need to have 1 point in each section. What are the points that we have right now? We have our x-intercept and our y-intercept. We have points in section 1. Technically, section 1 is going to be done, because once I join those points and go towards the asymptotes, it's not hard to draw section 1. But I have no points in section 2. So we need to have at least 1 point in section 2. And we get that by just doing a table of values. What would can you see that if I plugged in 3 for x, maybe even label this as a nice point. Sometimes your nice point might not even look that nice. But 3 is not bad. I could plug in 3. What would happen if you plugged in 3? What would you get on the top? You would get, and you might even want to go back to the original equation. 4 times 3 is 12. 12 plus 2 is 14. On the bottom, you'd have 3 minus 2, which is 1. So you'd have 14 over 1. So you have the point 3, 14. Okay, this isn't the nicest because 1, 2, 3, 4, 5. Oh my goodness. I'm going to just assume this is about where 14 is. But now that you have that point, you can just draw it towards the asymptotes. And you're done. But we have to have 1 point in that section. Someone might say, well, maybe because 3, 14 was really high, maybe I would choose 4 for my nice point. If you plugged in 4, what would you get on the top? You would get 16, 18 divided by, you get 4, 9. That's a little bit nicer, isn't it? 4, 9. You choose. But you just need 1 point per section, because once you have that point, your graph has to go towards the asymptotes after that. So as soon as I have this point, I'm like, I know in section 2 it's either going to be here below or here above. Other things to be careful of. When you find your x and y intercepts, you find them all. So you can never add new x-intercepts to your graph afterwards, because you already found all the x-intercepts. There can't be any more. So be careful that you're not adding x-intercepts. So I already knew that it probably couldn't be in this section because it would draw another x-intercept then. Question? An oblique asymptote are the diagonal ones. We're going to get to that soon. Okay, questions you can circle for number 1 are 5.